Hello everyone, my name is Drew Patel, and today I'll be discussing Lab 2, which is about lines of charges. To introduce the lab, the purpose of the lab is quite similar to the last one where we are observing and analyzing the interactions between the tapes, but instead of one charge point, this time we're assuming that it is uniformly charged objects. The fundamentals of this experiment include the understandings of the Coulomb's law and how we can apply it to more real-world conditions with uniform line charges. As per assumptions, we're assuming that the tape is completely static and isn't moving at first, and then when it does move, there's no air resistance. We're also assuming that the charges in the tape are evenly distributed along the tape. Next, these are some of the helpful formulas that we'll be using to show the difference between the models and their accuracy to the real life conditions. Of course, we'll be using Coulomb's law, the electric field formula for the uniform rod, electric field point charge formula, and the force of gravity due to gravity when calculating the charge. Now the setup and the data is quite similar to the last lab where we do the procedure as per the last experiment. Yet we now assume that the tapes have evenly distributed charge along them. Therefore, we can calculate the force of gravity as usual and then equate it to the uniform rod formula rather than the point charge formula and get the charge of the tape to be 7.88 times 10 to the power of negative 9 coulombs. This is possible uh, because we're assuming that there's no other forces acting on it and the net force is 0. This is the result of my glow script where I calculated the electric force with the point charge formula from the previous experiment and compare it to the gravitational force. Not only that, but the bottom code also shows a visual representation of how a uniformly charged tape would look like in terms of vectorial electric fields and the netted electric field canceling each other with the white arrow pointing up for the electric field and then the yellow arrow representing the gravitational force, and both of them cancel each other, equaling to the net force of 0. As per the discussion questions, the difference between point charge model and the distributed charge model is clearly shown here, where I got the value of 1.4 times 10 to the power of negative 9 coulombs for the point charge model, but I got 7.88 times 10 to the power of negative 9 coulombs for the distributed charge model. In the real world, the distributed charge model is much more efficient and accurately represented, especially when you add more and more charges to the model. Because the more more charges you add, the more accurate the resultant value becomes to and it is much more closer to the real value. Thank you for listening, and goodbye.